Assalamu alaikum. My name is Shahzad. I am lecturer Department of Computer Science. Our today's topic is database environment. We will discuss the following topics. These are data models, their categories, history of data models, what is schemas, instances and states, then the three schema architecture. After that we will talk about data independence, then the languages we are using for creation and management of database management systems, then the types of databases, especially centralized and client server architecture. At the end there are some distributed DBMSs. The data model, as we talked in the previous lecture, data model is a set of concepts to describe the structure of a database. That can be the operations for changing these structures and certain constraints that the database should obey. These constraints are on valid inputs. For example, we can say that the student ID should be in numeric form. These are called constraints. The data model structure and constraints. Constructs are used to define the database structure. These includes the elements and their data types, as well as group of elements. For example, entities. Entities are basically tables. The records are a complete information for a specific instance. Then the tables are entities that create entities are at design time and table are at implementation time, and the relationship between these entities. Constraints specify some restriction on these values data as we talked about earlier. The operations on data model. These operations are used for specifying database retrieval. Retrieval means for accessing a specific data, and updates. Updates mean an update in data. For example, we want to change the address of a specific student. These are called updates. Operation on the data model may include basic model operation. These are generic insert. Insert means insertion of a data, new data. For example, a student applied for admission in Allama Iqbal Open University. It's filling the form. Basically, that data should be moving towards database. That's called insertion. Then the deletion. Deletion means we want to delete a specific data from database. Update means we want to change that data. And there may be some user defined operations. That can be, for example, we are calculating the average marks of students. These are called user defined operations. The categories of data model. There are three categories of data model. First one is conceptual. Conceptual model means high level or semantic data model. This model provides concepts that are close to the way many users perceive data. So we are presenting database like a user. The data user can see, the data user can use. That's also called entity based or object based data model. Its main or core examples are entities, attributes and their relationship. The physical data models. These provides concepts that describe details of how data is stored in the computer. The core examples are files, indexes, partition. These are usually specified in an ad hoc manner through database management system design and administration manuals. The third one is implementation models. In these models, the concepts are provided that fall between the above two, used by many commercial database management systems implementation. For example, a relational data model, that's most used data model. Then the schema. What is schema and what are instances? The schema is basically the description of a database that include description of tables or entities and their attributes, their relationships, their data types, and the constraint on these databases. The schema constructs a component of the schema or an object within the schema. For example, student is a construct, course is a construct. That's a schema. That's complete called a schema. When we call it an instruct, the student is basically a construct. So prerequisite is a construct, grade report is a construct, section is a construct. So these all are different constructs. So we call it, these are instances, and overall we can say this diagram a schema diagram. What is a state? The actual data stored in a database at a particular moment in time. This includes the collection of all the data in the database. For example, in the previous slide, if we show the records on this slide, these are basically a state. The table course have 4 records at this stage, the section have 6 or 7 records. So that's called state, a specific time. The term instance is also applied to individual database components. For example, record instance, table instance, entity instance. So entity instance mean at a specific time all the records in that entity or table. The record instance mean the situation of that record. Database state refers to the content of a database at a moment in time. However, an initial database state is when we turn on or powered on the system, that's referred to initial database state. The valid state is a state that satisfies the structure and constraint of the database. For example, at a specific time, and we want to check the state, and there are some entries that are not supporting the constraints applied on the database, it means that's not a valid state. The distinction between database schema and state. The database schema changes very infrequently. Basically, schema is at design time, but the database state changes every time the database is updated. We want to insert a record, so state changes. We want to update a record, so state changes. We want to delete a record, so state changes. Schema is also called intention, however, state is also called extension. The 3 schema architecture. So we discussed about different views. So that's an external view, means end user point of view, and then the conceptual view, and at the end there is an internal schema. So we will discuss about internal schema, external schema, and conceptual schema. That's define database management system schema at 3 levels. Internal schema is at the internal level to describe physical storage. Basically, we are talking about physical schema. We see all the things in the context of storage, in the context of physical things, for example, files, locations, and drives. These are called internal schema. In the case of conceptual schema, that deals with at the level of concepts to describe the structure and constraint for the whole database. for a community of users. We see it at the user level, like a user can see or use. The third one is external schema, that's at the external level to describe the different users' views. Usually uses the same data model as the conceptual schema. Then what is data independence? Data independence means we can use data in any application without a specific software. The capacity to change the conceptual schema without having to change the external schema and their associated application program. For example, a schema is developed or used in a specific website. We can use this without a software that's used for the development of that website. The physical data independence means the capacity to change the internal schema without having to change the conceptual schema. For example, the internal schema may be changed when certain file structures are recognized or new indexes are created to improve database performance. The database management system languages. There are two types of languages that's mostly used. First one is data definition languages. Data definition languages are those which we are being used, mostly of being used for creation of databases, for development of databases. And the second one is database manipulation languages that are being used for maintaining or manipulating the databases. In data manipulation, mostly we are using high level languages, and at less level we can use procedural languages. These include the relational languages like SQL. SQL is basically a structured query language that's a standard for writing queries that may be used in a standalone way or may be embedded in a programming language like C, C++, etc. Low level or procedural language, these must be embedded in a programming language. High level languages are basically easy to understand for a user, for a programmer, for a developer, for a human, and low level languages or procedural languages are difficult to understand for a user, for a human. Then the second one is data definition languages that's used by the database administrator for creation, for designing the database. To specify the conceptual schema, in many database management systems, the data definition language is also used to define internal and external schemas. In data manipulation languages, that's used to specify database retrievals and updates. Retrievals mean we are going to I am a student of Allama Iqbal. If I am a student of Allama Iqbal University and I want to access my data through my user, so basically we are retrieving that data, and updates are performed by mostly by administrators or admin staff. Then the data manipulation language commands can be embedded in a general purpose language. These commands are update, delete, insert. Alternatively, standalone data manipulation languages commands can be applied directly using a query language. Standalone query language interfaces are, for example, we are entering SQL queries at the database management system in interactive SQL interface that's called SQL Plus in Oracle, or programmer interfaces for embedding data manipulation in programming languages. These are mostly user friendly interfaces that can be menu based, that can be form based, that can be graphical interface based. The programmer interfaces for embedding data manipulation language in a programming language are first of all we can use embedded approach, in which we use different tools like SQL J for Java, SQL C for C. So these can be used for embedding the queries in all these languages. The second one is through procedural call approach. JDBC for Java or ODBC for all other programming languages. Through these APIs we can use or write queries in those languages. Query is basically a procedure. Query is basically a procedure for asking database to do a specific task. For example, to insert some data, to update some data, to delete some data, to create a table, these all are called queries. Queries can be written in both ways, in standalone way or in a specific programming language. Then the user friendly database management system interfaces that can be menu based. These are popular for browsing on websites. Form based, these are designed for new users or novices. Then the graphics based, these are drag and drop and point and draw based interfaces. Then the natural language, basically the user requests these things in written form in a normal human understandable language like English. We can use all these interfaces with the combination of some. Typical database management system components are, first of all we will discuss the different types of users. These are called, first one is called database administration staff. The core responsibilities are creation. So we use data definition language statements, then they write the data definition language statements or queries, then the compiler, DDL compiler should execute them and send them to data dictionary or repository. So these are saved in data dictionary, and most of these commands are privileged only by DBA staff. Then the casual users who use these, they write interactive queries, and the query compiler compile them, and the query optimizer optimize them. The core role of query optimizer is basically processing of query in minimum time. These are called query optimizer with minimum resources. That can be a memory is a resource, a time is a resource. So they also access these data from data dictionary. Then the application programmers are those people who develop different applications for use of database. That can be a developer that's developing a website, or a developer that are basically developing a desktop application. All these are application programmers. So application programmers write application programs, and they are pre-compiled. Then data manipulation language compiler process them and ask the data dictionary for different queries, for different tables, access, or we can say schemas. So the last user is basically parametric user that compile different transactions. Transactions are basically those things that combine multiple queries. For example, like a transaction, financial transaction, we want to check our balance from a database of a bank through ATM. So there are multiple things, multiple queries. First query is basically verifying our credentials. The second query is about our balance or our financial things. So they combine them, and that's called a transaction. The last thing is basically the database. Database is a separate place where only data is stored. All routines are in data dictionary, and the runtime processor only access these routines through these routines with the help of different queries. So concurrency control and backup recovery, these are also relevant to database administrators. They are responsible to perform Backup and recovery. Backup is basically keeping different copies of data at different times. That can be a schedule or can be at any time. So the recovery means if our database crashes and some records and we lost some records, so the process of getting back is called recovery. Then there are different types of databases with respect to one location and multiple location. So first one is centralized. Centralized database architecture is in which all the database server, all the data is stored at one place that combines everything into a single system, including DBMS software, including hardware, application program and user interface for processing these software. User can connect these through a remote terminal. However, all processing is done at a centralized site. Site means that can be one machine or can be multiple machines, but at user point of view that's one machine. Means user accesses one location and it's showing that all these are at one place. A physical centralized architecture. There may be multiple terminals. That's a system. The terminal display control is basically a location where user can see all the activities. Application programs, these are installed on this machine. Text editors are those software with the help of whom we are going to write different queries. Compilers compile these queries. DBMS is a software that manages all these things, and operating system, that's normal operating system on that machine. Operating system is basically a software that manages all the things for running a computer, but at the above layer there are different softwares that can be database management system and can be compilers. Then the two-tier or client server architecture. In client server architecture there are two layers. One layer is called client layer and the second layer is called server layer. Servers can be with specialized function, that can be a print server. We develop or we mark a machine as print server, and a printer is attached with that, and all the users of that network is sending basically print to that machine. That's called a print server that manages the printing. The file server manages the files or data of any organization. The database management system server, the DBMS server is a machine on which a database is installed. Web server is a machine on website is hosted basically, and email server is a machine that sends and receives email through that. Client can access these servers when needed. The logical two-tier client server architecture is basically there are some clients that they can access any server. Clients can generate a request and server can respond these requests. Clients are provided with appropriate interfaces through a client software module to access and utilize the various server resources. Clients may be diskless machine or PCs or workstation or smartphone with disk with only the client software installed. These are connected to server via some form of network that can be local area network, can be wireless, can be wide area network, can be a mobile network. Then the server, database management system server, provides database query and transaction services to the clients. The application running on client utilizes an application program interface API to access server database via standalone. These APIs can be ODBC or JDBC. For example, a website is hosted on a web server, so the user can access those websites via a browser. that's an application program. Then the 3-tier client server architecture. There the first tier are clients that can access through a GUI or web interface. Then the database server layer that manages the database, and the third layer is basically application program layers. In the above example, we are discussing web pages are programs that user or clients access the server through these pages. Then the classification of database DBMS. Based on the data model used, there are different types of data model: relational data model, network data model, hierarchical data model. These are classical ones. And then the object oriented and object relational. We will discuss these in preceding slides. Other classifications are single user and multi-user. Single user mean a database is created or developed for a single person. Single person is a user for this system. That's called a single or personal computer databases. And the multi-user mean the most database DBMS have there are multiple users, like a university database is a multi-user database. Number of students accessing these and number of teachers are also accessing these. Then the centralized, as we discussed in previous slides. Then the distributed. Distributed means the databases are DBMS are divided in multiple locations. These can be homogeneous, these can be heterogeneous. Homogeneous means all the machines are having the same DBMS and operating system. Heterogeneous means different servers, different database servers having different operating system, different DBMS, in some cases may be different schemas. Then another form of distributed databases are federated databases or multi-database system. Federated databases are basically there are different databases with different schemas, even with different records. They are combined for users at one place. For example, when we are using a website for shopping, that's basically a federated database. They are connected with multiple suppliers and multiple sales personas. Distributed database systems have now come to be known as client server based database system because they don't support a totally distributed environment, but rather a set of database servers supporting a set of clients. Then the data models. There are multiple data models, so we discuss some of them in next slides. First one is network model. Network model that was first invented or implemented by Hanif in 1964-65. In those, the records or data are stored like our network nodes. In these all the entities or all the records are stored in the form of parent-child relationship. They only have single parent. The advantages of network model are that is able to model complex relationships among different semantics, different entities, that can handle most situations for modeling using record types and relationship types. However, the disadvantage of this model is that they can't handle much complex relationships. And the second one is they can't support multiple parent, multiple child relationship. That's called many to many. Then the second model is hierarchical model. Hierarchical model is a simple model like an organizational hierarchy that can be used with multiple parents and multiple childs. That's simple to construct and operate. Its language is also simple. For example, We can use get unique, get next, and so on. The disadvantages or difficulties with this model was that's navigational and procedural nature of processing. The second core disadvantage is limited or less query optimization. Some most important other models are relational model. In relational model, we store data in the form of tables. These are like tables in Excel. Relations are basically the relation between rows and columns. The most widely used database is relational model. The next one is object oriented model. In object oriented models, we can use different object orientation properties like inheritance, encapsulation in database concepts. The most recently invented and used model is object relational model. In object relational model, we combine the properties of relational model and object oriented model. We will discuss all these models in next chapters. In today's program, we discussed data models and their categories, the history of data models, schemas, instances, then the 3-tier architecture, then the data independence, the languages we are using for database creation and maintenance, then the DBMS utilities and tools, and at the end classification of the database management system. That's the end for today. Thank you so much.